Welcome to this video on calorimetry problem solving. In this video we are going to try to solve problems related to calorimetry and get some practice and see, find out some nuances on how to go about doing that. Before we start, let's quickly look at the units because we will have to deal with a lot of units. So first one is, let's look at specific heat capacity. So far we have looked at the unit of specific heat capacity as calorie per gram per Kelvin. Of course this would be equal to 4.18, or to be approximating it, it could be said 4.2 joules per gram per Kelvin, because 1 calorie is 4.18 or 4.2 joules. Now 1 joules per gram per Kelvin is, you can write it as 1 joules per 10 power minus 3 kilograms. That's 1 gram and Kelvin, and that's equal to 10 power 3 joules per kilograms per Kelvin. So that's you can write it as this, or you can also write it as 10 power 3 joules is 1 kilojoules, 1 kilojoules per kilograms per Kelvin. So joules per gram is same as kilojoules per kilogram because you added kilo in the top and the bottom, but in terms, if you want to write it as joules per kilogram, then you have to multiply it by 10 power 3. So with this in mind, let's get started with the problems. The key to problem solving in calorimetry is to encode the problem in the form of a diagram. So let's look at the first problem. So first one is what mass of liquid A? So we know there is liquid A, so let's draw that, and labeling this is very important. So A, specific heat capacity is 0.84 joules per gram per Kelvin at a temperature of 40 degrees. T1 is 40 degrees Celsius. Must be mixed with 100 gram liquid. This is 100 grams liquid. We don't know this mass is MA, let's say, of specific heat capacity 2.1. So C is 2.1 joules per gram per Kelvin. Pay attention, we are not at solving the problem. We are just writing the given information at 20 degrees Celsius. And the temperature of the mixture becomes 32. So this becomes 32. So this also becomes 32. All right. So the first thing we need to do is to make sure the units are consistent in both sides. That means that if the mass is in gram, this side also should be in gram. If this side is joules per gram Kelvin, this side also should be joules per gram per Kelvin. So if that much is taken care of, then half of the problem is solved. Of course, the other thing you need to make sure is, if this mass is in gram, this C also should be in per gram. So all of those are met. So the mass and the C units are same for A and B. So that's what we need to check. So if it is same, then we are all set. Now look at this. T1 loses, or is going down in temperature. So there is a delta Q loss, and this is a delta Q gain because there's an increase in temperature. And let's now, first, your starting point is write the law of calorimetry. Delta Q lost equal to delta Q gained. And lost here is only one thing, that's A, which lost. So this is MC delta T of A, MC delta T of B. It may make sense to write your delta T also for A, delta T for A is 40 minus 32, 8 degrees. And here delta T is 32 minus 20, and that is 12 degrees Celsius. So it makes sense to write your delta T also. So let's now translate. We don't know the mass. Specific heat is 0.84 into delta T is for A is 8 degrees Celsius. That's equal to the mass for B is 100 grams into C is 2.1 joules per gram per Kelvin into 12. I urge you to pause the video and do the calculation yourself and find out what's the mass. You would get the mass as 375 grams for this. So once you can see that once you encode the given information in the form of a picture and make sure all the units are consistent, that's half the problem solved. So let's use the same approach and let's try to do this for the second problem. I would urge you to pause the video and try to do it yourself. Try to represent the given information and check is our representation correct. So let's see how to represent this. So you have first the metal, a 50 gram of certain metal. So M equal to 50 gram. At temperature is 150 degrees Celsius. Immersed in 100 grams of water. So M is 100 grams at temperature 11 degrees Celsius. The final temperature is 20 degrees Celsius. So final temperature for both will be same. Now note that we have labeled this here. The labeling was not there, but we have labeled both of this. Now the C for water is given as 4.2 joules per gram per Kelvin. The C for the metal would be we need to find the C for the metal. So we need to find what is CA. We don't know that. All right, so now that we have written the given information, let's do a bit more. So here the delta T would be 150 minus 20, that's 130. And here the delta T would be 20 minus 11, that's equal to 9 degrees Celsius. Let's check if all the mass are of the same units. Yes, they are of the same units, and the mass and the specific heat capacity is also per gram. So we are all good here. Now here there is a loss of, or the temperature goes down. So this is delta Q lost, and this is delta Q gain. Now once we do that, the step 2 is solving the problem. Delta Q lost equal to delta Q gained, and that is MC delta T of A is MC delta T of B. Mass is 50 into C we don't know, into delta T is 130. The mass is 100 here, into C is 4.2, into delta T is 9 degrees Celsius. So I would urge you to pause the video and calculate and find out what is specific heat capacity. If you would have got CA as 0.582 joules per gram per Kelvin, you should have got that. So check that. All right. So let's do the next problem, and here again I would urge you to pause the video and try to write the given information in the required format and check if our information representation is correct. So pause the video here. So here is a given information representation. We have the copper and the water mixed up. The temperature is we don't know, so we put T, and we know that since this is at a higher temperature, this would lose the temperature, and here there would be gain, the temperature would be gaining here. So that's why we know what is loss and what is gain. All right, now let's encode the equation for this. This is mc delta T of A equal to mc delta T of B, which is 45 into C is 4.2 into 50 minus T equal to 50 into 0.39 into T minus 18. So I would urge you to pause the video here and try to solve this equation for yourself. One hint is, you have to, instead of having big numbers on both sides, it may be easier to have a number on one side. So what I mean by that is, you can bring either divided by 50 into 0.39 on one side and keep, this is not by, don't read this as by, it can be misinterpreted. And then you can make it T minus 18. So you can make this one small number and try to multiply with 50 and T and so on. All right, so I'd urge you to pause the video and do your calculations and find out T. If you get T as 47 degrees Celsius, you're right. So that's what you would get. If you don't, then try to decode where you went wrong. All right, so here is the next problem. I would again urge you to pause the video and try to visualize this in the form of a picture and represent the given information. So pause the video and give it a try. So here is the given information represented. So this is a kettle, and the mass, the specific heat capacity, temperature, and also delta T is 75 degrees Celsius. So we have represented everything. Now let's check the unit and consistency of units. This is in kilogram and this is in joules per gram. So we have a problem there. So let's either make this joules per kilogram or make this as gram, mass. So making mass into grams is a much easier thing to do. So let's do that. And if you look at here, this is kilowatt, and T will be in seconds. So, in the kettle, the energy is being given by this heater, and this heater is giving a delta Q, and delta Q of heater, right? Let's say heater is the power into time. So the watt is joules per second, but it's given in kilowatt, so it's better to write it as watts, 1250 watts, right? That'll be 1250 joules per second. So 1250 joules per second into T seconds. That's 1250 T joules. All right, so on one side you have the heater, and the other side you have the heat gained. That is mc delta T. That would be mass is 1000 grams into C is 4.2 into delta T is 75. And this is also, if you multiply all this, it'll be in joules, because this is in gram, this is in joules per gram Kelvin, and delta T 75 Celsius or Kelvin is the same. So I can say into, this is K again. Doesn't matter if it is K or Celsius because it's delta T. So this is also equal to 75 Kelvin, right? All right, so if you see, all of them cancel out and nicely, and you'll get joules. All right. So now the Q given by the heater is equal to delta Q gained. So if you equate this as 1250 T is equal to 1000 into 4.2 into 75, and then you can find out the T. So I would urge you to pause the video and do your own calculations here. So you would have got T as 252 seconds. This also can be written as 4 minutes and 12 seconds. So that's your answer. So I hope you enjoyed this video, and I would urge you to do more problems, especially the solve problems from your textbook, to get more practice and be comfortable with these kind of problem. So I hope you enjoyed this. See you until the next one. Ciao.